Right. Hi students, welcome to the course Solid State Electrical Drives, and today's topic is fundamentals of electric drives. So we know the electrical drives, what is a drive and what is the electric drive, and the fundamentals related to electric drive that we can discuss in today's session. At the end of this session, you will be able to understand the definition of the electrical drive, and you will be also able to understand what is a drive and what is an electric drive, and also you will have a complete understand or idea on block diagram of electric drives, which is very important topic. So first of all, you have to know about the drive. What is a drive? A drive which is used to control the motion, which is required in a large number of industrial and domestic applications like transportation systems, rolling mills and paper mills, textile mills, machine tools, fans, pumps, robotics, and washing machines, etc. Wherever the motion is there, wherever the rotation is there, to control the rotation, a drive is required. So a drive is nothing but a system that is employed for a motion control are called a drive. A drive is nothing but a system which is used to control the rotation or a motion, okay, of a machine. Okay, if this drive employs an electric motors is known as an electric drive. If the drive consists an electric motor, then that drive is called an electric drive. That is the definition. So the basic definition of the electric drive is nothing but the drive is a system which is used to control the rotation of any electrical machines. Okay, if a drive consists an electric motor, that drive is called an electric drive. So that is the definition. If you see the block diagram of an electric drive mainly consists of six blocks. Those are, first one is a source, and second one is a power modulator, the third one is a motor, and the fourth one is a load, a fifth one is a sensing unit, and the final component is control unit. Now let us briefly discuss one-to-one. Okay, one-to-one block. So that is first one is a load. What is a load? A load is load is designed to accomplish a given task. A load is see, I'm starting with the load. Okay, a load is nothing but it is designed to accomplish a given task. For example, fan load, a pump load, a robot is also a load, washing machine is also a load. Okay, machine tools is also a load, and trains and drills. So all these are designed to accomplish a given task. Fan is to rotate, pump is to pump the water, washing machine to wash the clothes. Okay, so all these loads are designed to accomplish to their given tasks. Okay, so according to the desired task, we will choose the load. And second one is motor. What it will do, motor, and how it will choose them. So the motor is specified in terms of speed and torque demands. Whenever you need to purchase any motor, that is specified in terms of what is the RPM and what are how much Newton meters or torque is to be generated. Okay, based on these parameters, the motor has to be selected, and it should have a speed torque characteristics and capability, speed torque characteristics and capability compatible to the load. That is very, very important. This motor should have the speed torque characteristics capability compatible to the load. So for suppose the load is desired to for a specific task, for a specific torque. So the torque, load torque and motor torque should be matched. That motor torque should not be less than the load torque. Otherwise, the motor cannot handle the load. The motor cannot handle the load. So based on this compatibility of speed torque characteristics of the load, we will choose the motor. I will choose the motor. And then a power modulator. A power modulator is, see, yes, this is the power modulator. The power modulator, which it will modulate the flow of power. It will modulate the flow of power from the source to the motor. So whatever the source we are giving, that power modulated by power electronics, power electronic device, that is a power modulator. It will modulate means it will convert, it will rectify, it will invert, it will chop. So power electronic modulator will modulate the power flow from the source to the motor, so power modulator will be in between the source and the motor. And also, what is the purpose of the power modulator? The purpose of the power modulator is to restrict the source and motor currents, both currents, source current as well as motor currents. Both currents can be limited, restricted by the power modulator within the permissible values. That is very important. Within the permissible and safe values during the transient operation. If the sudden load is added, then the currents will goes to peak. If suddenly load is reduced, then currents may be fallen very quickly. So these limits will be maintained by the power modulator. And also it will convert, power modulator will convert the electrical energy suitable to the motor, that is AC to DC or DC to AC or DC, fixed DC to variable DC, fixed AC to variable AC. Okay, like that it will converts. And it selects the mode of operation. That is very, very important. It selects the mode of operation, means forward motoring, forward braking, reverse motoring and reverse braking. That is the mode of braking. Okay, so among all these functions, the main function of the power modulator is to convert the electrical energy. So it will convert the electrical energy, means from AC to DC or DC to AC or DC to DC, like that. All these functions can be accomplished by a power electronic modulator. Then sensing unit. The sensing unit, this is the sensing unit. The sensing unit, it senses the certain drive parameters such as motor current and speed required either for protection or for closed loop operation. So the sensing unit, the purpose of the sensing unit is to sense the motor parameters like speed and torque for protection purpose or to closed looping, or for closed looping. Okay, protection purpose or for closed looping. So that is how the sensing unit will be useful. And the last one is the control unit. Last one is control unit. The control unit, it will controls the power modulator, and it operates at much lower voltages and lower powers, because it requires very, very less power. It operates power modulator as desired, and it generates commands for power modulator. It will generate command signals to the power modulator. So in brief, I can say that the source will be converted by power modulator, and then it will convert and it will gives to the motor, and the motor is driven will drives the load, and the sensing unit will sense the signals, and then the sensor signals will be sent to the control unit, and the control unit will compare the sensing unit and input command, and then it will generate the command signals to the power modulator. Then power modulator, accordingly power modulator will changes its operation of the drive. So this is all about the block diagram of the electric drive. Okay. So in the next section, in the next session, we can see the nature of the motor torque parameters. Okay, thank you. My Rosna.